So this is continuing in Chapter 8, Section 1. We're still doing our introduction to hypothesis testing. And we're going to look at an example of finding the critical region and more importantly, finding the critical value for our critical region. So in this case, all of these are going to be a critical z value because we're going to be assuming that we're using the standard normal distribution. So this is example 8-2 and page 423 just for your reference. Okay. So in these it says using table E in appendix A, find the critical values for each situation and draw the appropriate figure showing the critical region. And now in part A, it says a left-tailed test with alpha equals 0.10. And so I don't know how to write the words left-tailed test without taking a million years. So I'll just write that symbol, arrow pointing to the left, and I'll say alpha equals 0.1. We'll make a sketch of our distribution. Okay, approximately like so, just a simple bell-shaped curve. We'll sketch the appropriate critical region. So it is a left-tailed test. And here, since it is a left-tailed test, we have alpha equals 0.10. And so here, just next to the area, I'll indicate that value of alpha by just jotting down that value of alpha. All right, so we'll go to the table E for our standard normal distribution table. And remember that this is one where we have to find this value 0.01. We have to find that value in the interior of the table and then come out with the z value from that. So let me pause and find that particular one. All right, so we looked up in here and we found not exactly an area of 0.100, but we got as close as we could to it in the table. It was 0.1003, and that came at a critical z value. So here, say z subscript alpha has a negative 1.28. All right, well, let's look at part B. Part B states that we're going to do a two-tailed test and use alpha equals 0.02. So here's how I spell two-tailed test. And alpha equals 0.02. All right, so let's sketch a picture. All right, there's our bell-shaped curve. Good enough. That and that are the two z values. So this has two tails, one going to the left and one going to the right. Okay. And you knew I couldn't resist. Had to erase it and try to muddle it up a little bit better. There we go. Okay, sure. That's where I'm going to stop. Okay, so in this case, we have alpha equals 0.02, And we have that split, we have that divided over these two tails. And so just doing 0.02 divided by 2, we come away with 0.01 for the area underneath the left tail and 0.01 for the area underneath the right tail. And so there we can go to the standard normal distribution table and look up these values. We'll start by just finding as close as we can get to 0.0100. And then we won't have to bother with this one on the right hand side, because once we know this z value, we will automatically know that z value. So as close as we can get to 0.0100, that would be, where do I see that? I see that happening at negative 2.33 for our z value. Okay, so negative 2.33. We couldn't get exactly 0.100, we got 0.099. That was as close as we could get to the area of 0.01. So what is this z value on the right? Well, that would just be the opposite, positive 2.33. All right, so one thing to notice is that this area on the left-hand side, right, the z value that you find first should be the one on the left-hand side, and it should be a negative value. All right, we know that. All right, in part C, it says we're looking at the critical region for a right-tailed test with alpha equals 0.005. Okay, all right. So it's a right-tailed test. We have alpha equals very small, 0.005. And here's a sketch of the region, right? Here's our distribution curve. Here we have this z value. Don't know what it is yet. Haven't looked it up yet. This area underneath the right tail is alpha. And what is it? Is 0.005. And I'll just go ahead and add on an extra little zero there, because we're going to try to find the z value that gets us an area, a value inside our table, as close as we can get to 0.005. All right, so here I'm seeing pretty close, even closer. Oh wow, okay, so close. So we have negative 2.58. Z equals negative 2.58. Oh, wait, that can't be right. That's not a negative value. That's on the right-hand side of the 0 in the middle. That can't be. Oh, but look at that. We didn't commit a critical error. We were looking at the z table, which gives us left areas, so we were looking at the z value over here that had a left area of exactly the same thing. And so all you have to do is switch it around. Just make sure you put in a positive z value. So here was an example of finding our critical values for z. These will then define where our critical region begins and where the non-critical region or the non-rejection region is as well. So we'll put everything all together and summarize our total complete technique for doing the traditional method of hypothesis testing, and we'll do that in the next video. Break this into chunks. Okay, see you after the break.